Hello students, myself Sumangla Viradhar. So in this video, let's see about miscellaneous about crypto related topics. So that is visual cryptography. Visual cryptography, it is a secret sharing scheme. It is absolutely secure and it is polynomial based secret sharing scheme it is. And here in visual cryptography, no computation is required to decrypt the underlying image. Just if you see, then based on that you can perform the visual cryptography and you can decrypt the images here. So we can start with the one example here, black and white image, create two transparency, one for Alice and one for Bob here. So in visual cryptography, so Alice and Bob have the transparency of two parts, okay, when that is what we call as a black and white image. So that black and white image has the two transparencies. One transparency image is with Alice and another one is with Bob here. So now here if I combine those two transparency, then I can retrieve back what is the actual image here. So that's why here for decrypting no computation is required here. So each individual transparency appears to be a collection of random black and white subpixels. So here what are the transparency you are having now? So the transparency contains what here? Random black white subpixels here. So if Alice and Bob overlays their transparency, then only the original image appears here. In the visual cryptography, you are having the two parts of the image. This is the first transparency image and this one is the another transparency image. It is contains what it is, actual images, okay, white and black, okay, but it shows in the form of the gray level because it is in the transparency that contains the combination of white and black, which derives as a, or if you are overlay, then you will get as a gray layer image here. So this transparency image and this transparency image, if you are overlay, then you can see this is your image, actual image. Little bit it is blurred here because you will get a gray level image instead of black and white image. So this is what we call as a visual cryptography. So here there are the different options of the overlaying is there. Either that pixel may be AB, it is the pixels of white, and CD, these are the pixels of black here. So while sharing between the Bob and the Alice, this is the, if it is white pixel is there, so then part of the some white pixels and then some part of the, okay, white and black pixels are there with the share 1 and some part of the white and black pixels are there with the share 2. When you are overlay, then you will get the, okay, what is the actual image here. So if I go for the black pixels, some part of this one it is there with the share 1 and some part of the this one is there with the share 2 here. If you are overlay, then you will retrieve what is your black image here. So if it is the white pixel, then you will get the overlaid image as a combination of white and black. It is like a grayscale in gray level image here. If it is a black image, if you have the transparency as a share 1 and share 2, if you are overlay, then you will get the as a black image. This is about your cryptography. Next is random numbers. So cryptography random numbers must be statistically random. They must be unpredictable. So what are the random numbers you will get now? So guessing of what is the next random number is not possible. So that is what we call as a unpredictable here. So for that one example is here, that is Texas Hold'em Poker. This is one of the card game. So here they used ASP software which is used to develop a online version of this card game here. So in this game, player has the first dealt two cards face down here. What are the players are there now? First they have to dealt their two cards face down. And once the betting takes place, then three community cards will be dealt face up. Okay. All players can see these community cards and based on that they have to play the game here. After one round, once again, next round betting will be takes place. In that, one more community card is revealed here. Later that, once again, the okay betting is takes place. Then the final round will dealt one more community card. That is the totally fine. Okay, 5 community cards are revealed. So after that, only one player who remained at the end will be the winner here. So here this online version of the card game, it is developed with the help of, this is the example, these are the cards which are there with the player's hand and these are the community cards which are open and it can be seen by the every players here. So these are the first, okay, three community cards are there. After betting in the second round, one more community card is revealed. After that round, once again betting will take place. At the end, one more community card is revealed. So based on these 5 cards, so we'll decide who are the winner here. So in this game, random numbers are required to shuffle a virtual deck of cards here. So that is the AFS Poker software is used. So here you are having the some flaws. What is that? Did not produce a truly random shuffle here. So for truly random shuffle means what? It is highly impossible. But in this one, what are the random number shuffling is takes place for the virtual deck of cards? No, that is the pseudo random here, partial random here. So that disadvantages can be advantage for the players who could take the advantage of this flaw, and they can cheat here. So how they will cheat? They will check the pseudo randomness, and based on that they will predict what are the next future community cards before they were revealed here. So this is the one of the drawback of the random numbers here. So as I told, if it is random number, truly random numbers means what? It must be highly unpredictable. So guessing of the random numbers must be highly impossible. But in this game, so it is as players can guess the what is the next community card will be revealed. Okay. So because this random number shuffling is takes place in the form of the virtual. Okay. So virtual deck of cards is takes place in the form of pseudo random numbers. Partial random numbers are shuffling takes place. Due to that reason, players can guess. Okay. So but generating random bits. So from this example, they reveal that truly randomness is difficult to achieve here. But one of the cryptographer, that is Shannon, explains entropy is a measure of the uncertainty, or it is predictability of a sequence of bits here. Okay, sources of true randomness do exist. Okay, based on the with the help of the entropy. So this Shannon explains that S true randomness is exist. So example for that are radioactive decay and hardware devices which are based on various physical and thermal properties that are unpredictable here. Temperature variations. Okay. So it is unpredictable. Another source of randomness is the lava lamp, which achieves its randomness from its chaotic behavior. So based on the chaotic behavior, you will generate the randomness. That is the example of lava lamp. And even software is deterministic, but true random must be generated external to any code here. And sources of randomness include mouse movements. In the this one, it may be the mouse movements, keyboard dynamics, certain network activities, and so on. All these are the example for true randomness here. Okay. Next is information hiding. So there are two methods are there in the information hiding. Those are steganography and digital watermarking. In the steganography, it is the hidden writing. It is an attempt to hide the fact that information is being transmitted. So here you are hiding the information in the another information. So you may hide the text in the image, or you can also hide the video. Okay, what are the video you are hiding? Inside that also you can hide images, or you can hide audios, or you can hide the another video also. So only you can see only one original image, but behind that you are hiding the another video or another image. Okay, that is what we call as a steganography here. Next is watermark. Watermarks generally involve hidden information, but for slightly different purpose here. So even in the watermark also you are having the hidden information. Usually watermarks it is to prevent from the copyright. For example, if I take your question paper also, for all the question papers you are having backside as a watermark, that is shows that this is the original paper you are received by the video. So that is the example for the watermark here. So in digital, watermarks can be categorized in many different ways. First one is invisible. Watermarks that are not supposed to be predictable in the media. So we are having the watermarked image, but if you see the image, you can't see what actually it is. Okay, what is hidden in that particular image? That is perceptual. Next is visible. So now some of the watermarks are observed. As I told you, a question paper also you can see what is the watermark here. Next, watermark can also be categorized as follows. Robust. Robust means what? It remain readable even if they are attacked. So watermark images, if it is damaged by the hackers or intruders, but it can be by damaged image also you can retrieve what is there, or you can read what are the informations are there. So that is what we call as a robust. Next is the fragile. Fragile watermarks are supposed to be destroyed or damaged if tampering occurs. If tampering occurs, then you are not trying to read what are the information is there. Simply they will destroy that. For example, okay. So if you are having the any information, that one if it is tampered, then there is the no use of taking such type of the images. Then just you can destroy. So these are the different ways of the watermark. One is visible, invisible. Invisible means what? It is watermark, but if anyone see, they can't tell that it is a watermark image. Okay, only owner who are inserted or who are created that watermark, that person only know that it is the watermark image. Visible means everyone can see here. Next is robust means what it is. Even if that image is tampered, then also you can read that. But fragile, so destroyed. Once if it is tampered, then simply you destroy that one. So next is steganography. Example for steganography. Usually colors are represented using the RGB. So this is the color, okay, hexadecimal value for this color R is okay 0x7E 0x7, okay 90. It's much different than, okay, if I take the one more version of this RGB, in the place of 7 if I take as a F here. So then what happens here? Even the colors only differ by 1 bit. Here in the place of 7, if you are change 7 by F also, what are the color you will get? No, that is color is totally different here. Color representation. Combination of RGB, you will get the different variations in the colors here. But in the variation also you know that 1 bit if you are changed, then you may get the totally different color. If it is red and green, if you are combined, you may get the totally different image like that. On the other hand, if the color is same thing, I'll take, instead of changing the middle one, last bit, okay, this bit if I changed, okay, middle bit if I change, then I can differentiate that the color is varied here. If instead of 0, if I take 1 in the last bit, then these two colors are represented by what it is indistinguishable. So means what it is, you can't differentiate between these two here. See, it looks like that both the images, okay, what are the colors you are changed a bit now, it doesn't shows that where the variation is there here. Okay, if you are see, it looks like both images are same here. For example, here this image, okay, it is having the last bit as a 0 and this image is having the last bit as a 1. Is it possible to differentiate between these two? No. So this is what we call as, this approach is used by the steganography to hide, okay, in the place of this lower bit they will hide the information. This is the one example. Color black is represented by the value 00, whereas white is represented by using the hash FFF. In the lower order bits of the RGB, it won't affect the pursued color here. If you hide the information in these bits, doesn't make the any difference in the, okay, your information. So here is the one of the snippet of the HTML. I think you already know that these things you already learned in the, okay, web development. So this is the font color and here you are representing the font color and this is your message and you are closing that. Like that you are in the one snippet of the HTML code it is. Now here in this RGB colors, I am hiding the information. What is that information? This is our information like this in the last bit. So what are the true values are there in the color? Those values I hide by using this bits here 101000. So if I hide, it doesn't make the any difference to your information because it shows only the last lower bits of the RGB colors are your modified, so that modified is not affect your color representation. This is how steganography works here. But hiding information in the lower order bits of the HTML color tag is obviously not as impressive as hiding the alias image here. So usually suggestion is what, instead of using the colors, if you are use the image representation in the image representation also, every lower order bits you can, okay, hide in the lower order bits of the images, you can hide the information. That is very impressive comparatively hiding the information in the color representation. So this is about your watermarking. Sorry, steganography here. Okay, so these are the some of the miscellaneous comes under in crypto relating. One is visual cryptography. In the visual cryptography, you are having the half a part transparency of the images two part. When you overlay those two transparency, then you can clearly see what is the actual image. So that's why no computation is required. Next is steganography. In the steganography, within one original image, you are hiding, okay, behind in that image, you are hiding the secret information. That information may be text or maybe video, but maybe image or it may be audio here. And watermark. So watermark is what it is. It is the watermark image here. Okay. Thank you.